is Katerina Peripichai, and today I would like to talk about luminescence, fluorescence, and phosphorescence. I would like to start with the general information about what is luminescence. So, it is emission in the optical range of the visible ultraviolet or infrared light, which is an excess over the thermal radiation emitted by the substance at a given temperature and continues after absorbing the excitation energy for a time that is significantly longer than the period of the light waves. Luminescence is inherent in substances in any aggregate state, gases, liquids, solids in crystalline or amorphous state, polymers, glasses, and organic and inorganic substances can luminescence. So, in the vast majority of organic substances, an organic molecule has the property of luminescence. Therefore, organic substances can luminescence both in dissolved and in the molten state. For inorganic crystals, the crystal lattice has a property of luminescence. Dissolved or melted crystals lose this property. So, what is the mechanism of luminescence? The mechanism of this phenomena is due to the fact that under the influence of an internal or external source, atoms, molecules, or crystals are excited in the substance, which then emit protons. Depending on the duration of the glow thus obtained, which in turn depends on the lifetime of their existing state, fast decaying and long-term luminescence are distinguished. The first is called fluorescence, the second phosphorescence. For a substance to luminescence, its spectrum must be discrete, that is, the energy levels of atoms must be separated from each other by bands of forbidden energies. For this reason, metals in solid and liquid states which have a continuous energy spectrum don't luminescence at all. In metals, the excitation energies simply continuously transform into heat, and only in the short wavelength range can metals experience X-ray fluorescence, that is, under the influence of X-ray radiation, emit secondary X-rays. So, what is the application of luminescence? You can use in decorative paints, watch dials, production of photo paper, luminescent markers, securities protection, you can use it for encoding, for example, tokens, luminescence tubes, the rapid CD, and in medicine, it is used to detect the cancer tumors, which use nanotubes, and diagnostic of multiple sclerosis. So next, let's talk about what is fluorescence. So it's like luminescence decaying for a short time after the cessation of existation. Fluorescence is observed in atomic and molecular gases. Many organic substances have fluorescence in liquid and solid solutions as well as in crystalline state. The fluorescence spectra, its polarization and kinetics are related to the structure and symmetry of luminescence centers or molecules. The nature of the interaction depends on the concentration of solution, the type of excitation, and so on. So, what is the application of fluorescence? It is used in manufacture of paints and dyeing textiles. For example, fluorescent pigments are added to paints, felt-tip pens, as well as when dyeing textiles, household items, jewelry. It's used also in technology. Fluorescent additives are often added to technical fluids, for example, antifreezes, which facilitate the search for leaks from the unit. Also, it is used in biology and medicine. In biochemistry and molecular biology, fluorescent probes and dyes have been used, which are used to visualize individual components of biological systems. For example, eosinophils, blood cells, are so named because they have an affinity for eosine, which make it easy to count when analyzing blood. Also, it can be used in forensics. Certain fluorescent substances are used in operational investigative activities for making notes on money, other items in the process of documenting the facts of bribery and extortion. They can also be used in chemical traps. So next, let's talk about what is phosphorescence. Phosphorescence is like a special type of photoluminescence. Unlike fluorescence, a phosphorescent substance does not immediately absorb energy. The most common phosphorescent material are zinc sulfide and strontium aluminate. It is curious that the well-known luminescence of white phosphorus upon contact with air, which gave the name of the phosphorescence phenomena itself, is also not phosphorescence but hemiluminescent, accompanying the process of phosphorus oxidation. So, what is the application of phosphorescence? The main field of application of phosphorescent material is product for use in emergency situations like emergency exit signs, direction making, and etc., which continue to glow after a power outage. Phosphorescent materials are often applied to the dials and hands of the clock, scales, and hands of instruments, which make it possible to read the indication in the dark, of course, until the energy accumulated by the phosphor is exhausted. Phosphorescent pigments are also sometimes used for coloring Christmas decorations and applying images glowing in the dark on clothes, as well as for the manufacture of various decorative products, paints, stickers, and etc. So that's all. Thank you for your attention. Bye.